May 2016. Find the slope of the tangent line to the curve, blah, 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 at the points 2 and 4. Okay, how do you know it's implicit? That's the first question.
X and Y.
Yes, you can't solve for y, right? Usually everything that you've seen is y equals. If you can't do that, usually it's some sort of weird ellipse like this. You can't solve for it, okay? So what do? As soon as you see the word slope and tangent line, what do you have to do? Derive it, right? Because the derivative is the slope of the tangent line. So, do we like square roots? No. So I'm going to remove this, rewrite the square root first. Okay, do you want to try it on your own? Do you want me to go through it with you? Okay, so first one. When I see a constant, I tend to just kind of block it out, so I put brackets around it. How you want to do that is, if you want to do that, is up to you, but usually I will just go, I'll go through the whole thing and do that. Okay, put brackets around the things. The other thing, it's not in this question, but if you get a question that looks like this, because this is a trips kids up all the time. I don't know, y squared is equal to 5. Say you had a question like that. This, I guarantee, will mess somebody up. Okay? Because that negative is going to both. So before you do anything in those cases, I usually go through and just put brackets around it like that. Okay? Does that make sense? Because all the signs will flip afterwards. Unless you can keep it all straight in your head. That's a common mistake. All right. So we're not doing that one. All right. This one over here. All right. Let's do this. So the 4 just stays there. Bracket. What rule do I need to use on x and y? Product rule, right? Do you mean like y as in WHY? Yeah. Okay. Because it's two functions being multiplied together. Oh. Right? So we have to use product rule. Product rule says what? What does product rule say? So the derivative of the first function. What's the derivative of x with respect to x? 1. Times the other function. No, that's what I read it too. It means this. That's just confusing. I know. It confused me.
We're just saying literally 2.
Plus 2 over x is equal to 5. 3 5. So that's not there. So it's just 3.
Okay, so it's just that. Okay, the wording was weird again.
Yeah. Thank you. Right. Okay. Times y plus the derivative of the second function. What's the derivative of y with respect to x? Y primed. Times the other function, which is just x. Bracket. Minus. What do I do with this y to the power of 1/2? Drop the half and take away 1 from it. So you get, but then it's chain rule. So you have to multiply by the inside derivative. What's the derivative of y with respect to x? Y prime. And then what do you do with the negative 3x squared? Negative 6x. That's just regular. Nope, because what's the derivative of 18? It's a constant. The derivative of any constant is 0.
So the first step is just derive all that?
That is the derivative of the above. Okay. Any questions about that step? All right. Now, you have a choice. You can isolate y, and if they are just asking for the derivative, you will have to isolate for y. Y primed, I mean, sorry. Okay? But if it's a question that says, what's the slope at this point? if you just plug in those for x and y's right now, it makes it easier. Do you know what I mean? Do you want me to isolate it as well, just for practice?
Yeah, sure.
Yeah. All right. So, what do you do if you're going to isolate? Well, you got to get all your y primes to one side, but first I got to dump that 4 in. 4y primed x. So that's just me dumping the 4 in. Then everything that doesn't have a y primed gets shifted to the other side. That makes sense? Now what? Yeah, now we factor a y primed out. And then divide it off. Is that okay? And then, yeah, if they want, when they want the slope now, you just plug in your x's and y's. So I'll plug it in, but I'm not going to I'll just give you the answer. I'm not going to do all the math. So to get the actual slope, just plug in these 2 points to x and y. So everything that's in x, so y prime is equal to m. Everything with an x gets a 2. 6 times 2. Everything with a y gets a 4. And then whatever that is, I think it's negative 16 over 33. Is that okay? Peoples?
That is good.
Yeah, we okay? Okay. What was the next one? Exponential decay. All right. So this is, which one is this? That what we just did? That's chapter 2, derivatives. Did everybody, let me pause this. Okay, exponential decay. So yeah, I crossed it out because I did this last year. Radon isotope, half-life 3.82 days, meaning that this amount is blah, 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 blah. All right, what do you do? So does he allow you to just go straight to the equation for exponential decay? Or do you have to, I think he said that you can just write it out. Do you know what the equation for exponential decay is?
Yes.
What is it? Yeah, essentially, or like this. Y is equal to C e to the k x or kt. It's usually t because it's time, right? But do you remember seeing this formula?
Yeah.
Okay, so if you see the words exponential decay, you write that down right away.
We're gonna be given that. Yeah. Well, essentially, it's everything.
Yep.
So is it gonna be like exponential growth of decay? Like, because we did it like questions that weren't just like growth of decay, we did like the other stuff.
There's regular differential.
Yeah.
I can do an example of that.
Well, like no, but is this like the question that's gonna be exponential decay?
I don't know. I haven't seen the test. I won't even see the test probably till Tuesday or Monday night. So he hasn't made it yet.
When you see
But
it, you should let us know.
post it in the classroom for you.
Can you go through it and yeah, do a video on it and accident.
Okay, I'll get right on that. Okay. Has a half-life 3.82 days, meaning that its amount is halved every. If 20 milligrams have been released, how long does it take until only 1 milligram is left? All right. We do now. 20, right? Correct? That makes sense to everybody? This, remember, I think I said this the other day. This is the same formula that you had in Math 12. Except we called it like that. Remember that? So the only thing we've done is we've made this base E. We used to change that base to like 1/2 and all that kind of stuff. And we turn this 1 over x here. We're just calling that k is 1 over x. So that's why it's like that. That's all they've done. Okay. So if they tell you the initial amount, that is your C value. All right. So that's 20. That right there, C is equal to 20. So the formula is 20 e to the kt. Okay.
Oh, the question's weird because it seems like it's saying 20 milligrams has decay already, right?
No, yeah, I guess, but it's saying no, you've released 20 milligrams, or you start with 20 milligrams. How long is it going to take till you only have 1? That's what it wants you to figure out. Okay, we got to figure out K. How do we figure out K? We're not going to sketch the curve. Okay, we have to isolate K. So, what other information do we have here? So, okay, so we know. So when the half-life is 3.82 days, right? Correct? So that means that when t is 3.82 days, what does c equal? How much of the radon do you have? Not c, sorry. 10. Y. Y is equal to 10. Okay, does that make sense? Because 3.82 days is the half-life. We start with 20. So after 3.82 days, the half-life, you have 10 milligrams left. Is it milligrams? Yeah, milligrams. Okay, so we plug that into this formula. We get T is equal to 20 e to the k 3.82. I mean, you don't even really need to do that. Straight to the end. You need to find k, like how fast it's decaying, right? That's the, yeah, because this formula has 1, 2, 3 unknowns, right? We only want 2 unknowns, or 1 unknown really, but. Okay, so we divide off the 20. We get 1/2 is equal to e to the k times 3.82. What do we do here? Natural log it, right? If you natural log e, what happens? Sorry? You don't need to, because these are all positive numbers. You could email them. The right side is just going to be 3.82, right? Or k times 3.82. So if you go natural log of 1/2 divided by 3.82, you get k, which is negative 0.18. Somebody want to check that on their calculator, please? Is that right? Okay. So now we have our formula is y is equal to 20 e negative 0.18 k at t, sorry, not k. You should ask yourself at this point, does this formula make sense? Does it make sense as that is negative? Because it's decaying, so yes. Okay, so we know we're, hopefully on the right track. Okay, we've got our formula. Now they're asking us how long it takes till there's 1 milligram left. So what does the 1 represent? Does everybody agree with that? So our Y value is 1 milligram. It's the final amount. Yeah, that's exactly it. So you put in for Y. So you get 1 over 20. .6 approximately. Is that what other people got?
Yeah.
16.
Is everybody okay with that? Everybody agree with it?
Yeah.
Any questions about how to solve that?
So C is always the initial amount.
Yeah.
And then P is whatever you have at the time. I guess because like the question could be written differently. Like you could have K instead.
Oh, yeah, they could give you K and then you have to solve for time. But then they'd have to tell you how long does it take. Yeah, if they gave you K, then you're just not doing this bit, right? Define K. So it saves you a step. Yep.
So are these on the practice sheets because you guys are last week?
Yeah, these are all these examples I'm doing are from the exams.
So are there more questions or is this one?
The other exams might have some, yeah, I think so. And then I think in the classroom, I think I put exponential decay questions in there. Yeah, so if you go to chapter 6 in those special questions. Okay. Exponential decay. Curve sketching. That basically sums up all of chapter 3. Curve sketching and optimization will do all of chapter 3. Okay. So let's pick a decent curve sketching one. Ooh. I don't want to do that one. Curve sketching. There's a curve sketching with a log in it. Do you want to do that?
Yeah.
You want to do that?
Yeah.
Actually, it doesn't have XY intercepts, and I think yours will probably have XY intercepts. So I want to do one that has that. The key to that exam is in the classroom. So trapezoids. Okay, here's a curve sketching. Okay, we're going to sketch this curve. Now, on this exam, 2016, it's broken up into a whole bunch of different parts. Do you want to just do it all at once?
Yeah.
Like a regular curve sketching? Okay. All right. Okay. All right, here we go. All right, so yeah, like I said, this is 2016 exam, May 2016. When she wrote the test, she broke it up into different parts. So you'd answer each one and then put it all together at the end to get the curve. But we can just do it all at once. So just pretend that, hey, I'm saying, sketch this, okay? So first thing you should figure out before we do horizontal asymptotes is XY intercepts. So I'm gonna go off to the side. X-intercepts. How do you find the x-intercepts? Y is equal to 0. If you put y is equal to 0 into there, you get this. What happens? Doesn't work. It blows up, right? You get 0 is equal to 15 if you multiply that x squared plus 3 up. 0 is equal to 15, therefore none. Because it doesn't even make any sense. Who said y? You got it? All right. Y-intercept, that is when x is equal to 0, correct? So if you plug that in, 0 squared plus 3, 15 over 3, which is? There's your y-intercept, 5. You got a mark. 2 marks, I guess. I know, good job. Because it was worth like 12 on the other test. So I'm just going to say this is at 12. All right. We got to do asymptotes. So horizontal asymptote. Limit as x goes to infinity, right? That's a slant asymptote. My other video has one of those in it. The one from C-Block has one of those. All right, so the horizontal asymptote is the limit as x goes to infinity. Now, if you look at the other video, C-Block, the curve sketching question, you actually have to figure that out, okay? So this one, you can just plug in infinity, and what happens? You get that, right? So what do you get? 0. Therefore, you have a horizontal at y is equal to 0. All right, you get another mark. 3 out of 12. Okay, 3 out of 15. I don't know. We should do verticals. How do you find vertical asymptotes? Make the denominator equal 0. Where anything make the denominator equal 0? Will anything make the denominator equal 0? Nothing does.
Oh wait.
Because you're squaring something and then adding it. So it can never be 0, right? If you did the math, if you went, okay, the denominator has to equal 0. So x squared plus 3 has to equal 0. Well, you try to solve it. But if you try to square root a negative, it all blows up. So we're having an imaginary one. If you're graphing in the anyway, no. Okay. You can review that in second or third year calc when you get there. All right, so there's no vertical asymptote. We got our horizontal, we got our x, y intercepts. All right, now what do? We're curve sketching. First derivatives, here we go. It even tells you in this one. Use f prime to find the intervals where it's increasing and decreasing. Okay, so f of x is equal to 15 over x squared plus 3. How can you make your life easier before you do the derivative here? Flip the whole bottom up, right? Because it's just a constant up top. So you get 15, that. And then what rule are we going to use? Product. No, product. This is just a constant, right? So I don't care about it. You're going to use chain rule. So drop down the -1. Take 1 away, so that becomes -2. Multiply by the inside derivative, which is 2x. So we end up with -30x That's it written in simplified form. So what do we do now? Critical points. How do you find critical points? What makes it 0? You set the first derivative equal to 0. So what makes it 0? 0 is the only one, right? So x is equal to 0. That is your critical point. your crit. Is everybody good with that?
Yeah.
Okay. So I'm just going to do it here, but normally you do it all together at the end. You put your critical point there. You have to test either side of the critical point. Yeah, pick easy numbers.
They don't matter though.
The numbers don't matter.
No, but I'm saying it's not.
What?
What do you say?
I'll figure it out. I'm fairly confident I will. Okay, so any number on to the left of 0. Negative 10. If you look at this, you can make your life easier if you look at this, if you look at what you're dealing with sometimes. Is the bottom ever going to be negative? No, because you're squaring it, right? So really, you just have to look at the numerator. If I put a negative 10 into here, I get a positive number. So that means a positive over positive is positive. Everything to the left side, the derivative will be positive. That means it's going up. And if you put a positive number, like positive 10 in, what are you going to get? Negative. So it's going down. What does that mean is happening at 0? It's a max, yeah. Well, we don't know that yet. Yeah, we do know that. You're right. Okay. It's only ever decreasing after, right? Okay. Are we all right with that?
Yes.
So once you've done first derivative, what do you got to do next? All right. This is going to be fun. Let's just, well, they have space for it on the next page, but I'm just going to do it right here. Okay. Second derivative. Now, which form do you want to use? We got to do the derivative of this. Do you want to flip it up and do product? Is that what we want to do? Nobody likes quotient? Okay. So this, if I flip that up, this is what we're deriving. That, right? Okay, so that's product rule. Does everybody understand why that's product rule? It's two functions being multiplied.
Yeah, one function.
Oh, yeah. Because of that x right there. That's what makes it product. If it was a constant like above, it would just be a chain rule question. Okay, product rule says derivative of the first function. That's your first function. What's the derivative of negative 30x? Negative 30. Times the other function. Plus. Sorry?
So we're not saying it's negative 30x. It's like, oh, sorry.
All right. Then we do the derivative of the second function, which is this whole thing. What rule do I need to use on that? Chain rule. The negative 2 falls down times the other function, or times the inside bit. Take away 1, so I get negative 3, times the inside of that, which is what? 2x. But then you have to multiply by the first function again, which was negative 30x. Where people go wrong is they forget, because this bit is so long, they forget to multiply by the 30x. Does that make sense? Is there any questions about that? This is important. We're good? All right, now we got to simplify it. This is the part that sucks. Okay, well, let's clean up the left side. So negative 30, or the right side, sorry. Negative 2 and 2 is 4. 4 and 30 is negative 120. And then because there's two negatives, it becomes positive. So positive 120. And then these two x's become x squared. and you have x squared plus 3 to the negative 3. There we go. Now, I don't know. What do you want to do? Sorry? No. It's not 0. Okay, let me rewrite this as this. Oh, positive 3. Okay, that's the second derivative. How do you find your possible points of inflection? How do you find them? There is. How do you find them? Just tell me how to find them. You said the second derivative equal to 0. Okay, so let's do that. Okay. So I'm going to move this over here. So I'm going to get 30. Okay, what are you going to do now?
And multiply of x squared plus 3 and cancel.
Yes. So this is going to go up there. Is everybody okay with that? This is actually kind of a long question for. What do we go do? 20 after? Yeah, we'll be okay. This is from the final.
Dude, this would take a while.
I know. All right. So this. Bye. We actually don't care that goes away. Normally, I don't like doing that, but in this case, it doesn't matter because there's nothing that makes the denominator 0. Okay. Well, those are vertical asymptotes. So you're gonna have to account for those, right? So now I'm left with. This is getting ugly. Okay, we'll clean this up a bit. So I'm going to dump the 30 in here. 30x squared plus 90 is equal to 120x squared. How do you solve this? Yes. And it's a quadratic. So you're going to get everything to one side and factor. So I'm going to go move that over. I'm going to get 0. 120 minus 30 is 90. Is that correct? Plus 90. Minus 90, sorry. I'm going to factor a 90 out. And I'm going to get x squared minus 1. Which means what makes it 0? And? Negative 1. Because this is the difference of squares, right? So you're going to get... So your possible points of inflection, plus minus 1. Well, that sucks. Okay, now what? You have to do test the concavity, right? Minus 1, plus 1. I'm going to start rushing because I want to get the other stuff in. So F double prime. You test on either side of the possible points of inflection, and these are the possible points of inflection, PPOIs. I'm just going to give them to you. You're going to get positive, negative, positive. Thank you. All right. If you have a positive second derivative, what does it mean? Concave up. So the graph looks like that. If you have a negative second derivative, you are concave down, and then we're concave up. All right, we're ready to sketch. Are we ready to sketch?
Do we not have to find the actual point?
You can. You just plug plus or minus 1 into the original.
We're supposed to do that, right?
If they ask you, yeah. I can do that after we sketch it.
If they ask, who do they ask?
Okay, all right, hang on. Let's sketch this first. All right, so we're going to sketch our graph. What do we know? We know our horizontal asymptote is 0. So we have a horizontal asymptote of 0. We don't have any verticals. Do we have a y-intercept? 5. Right there. So it's F5. We have a max at 0. So that has to be a max, right? Our y-intercept is a max. The graph is increasing. Let me see if I can fit this in here. The graph is increasing from negative infinity to 0, and it's concave up to negative 1. So at negative 1, and at positive 1, it changes as well. We are increasing but concave up. Okay. After that, it switches to concave down, but the graph is still increasing all the way to 0. Looks like that. And then it's decreasing after 0, but still concave down. And then at 1, it switches to concave up, but still decreasing. That is a really badly drawn graph, but that's what it looks like. And obviously the points of inflection should be at the same height, not like mine where it's tilted.
Typically, we're supposed to find the actual point.
So if you wanted to find the values of this, the y value, is that what you're asking me? Just go f of 1 and f of negative 1. So put that into the original. So actually you'll get 15 over 4 and negative 15. Yeah, 15 over 4. Does everybody see that? They usually will ask you that. And they'll ask you for you at the maxes and mins as well. All right. Curve sketching. What do we got next? Opto and related rates. Monday. I don't really see that happening. Okay. What is this? It's 2016. Oh. Rate. Where's a rate problem? All right, you want to do this for optimization? This is 2017. Is this 2017? Hey. There we go. 2017. Here we go. Optimization. We can burn through this. I have faith. All right. Cylinder, radius r, height h, has a volume of pi r squared h. and a complete surface area, top, bottom, and sides of 2 pi r squared plus 2 pi r h. Find the minimal surface area if the volume is supposed to be 1,000. All right. What do I do? Okay, which is 1,000, right? There you go. It does not, but one will be easier than the other. Which one will be easier? H will be easier because you don't have to square root anything, right? Does everybody agree with that?
Yeah.
So I'm going to take our 1,000. I put it in for volume. I have this. I'm going to solve for H. You could solve for R if you wanted to, but you're going to have to square root it, and then your next formula will have a square root in it, which I don't want to deal with. So 1,000 over pi r squared is equal to H. Why do we want to do that? Exactly, because we're trying to minimize the surface area, the area. So you have to generate this formula so that it only has one variable. Right now it's got two, R and H. So I'm going to sub that in for H over here. So I get that. And now you need to simplify that first before you derive it. Pi's canceled, that R cancels that R. So I'm going to get 2,000 over pi r, which I'm going to write at 2,000 over pi. I'm going to flip the r up. Is everybody okay with that? Oh, the pi's cancel. Pi's not even there. Sorry. That cancels. Thank you. There we go. 2,000 r to the minus 1.
Slowly get over there. Okay. I remember that it's the whole of triangles G, but like this doesn't feel like work shown. Does that count as work shown?
I think so, yeah.
Oh, you think so? Okay. And second question, is this like the area between two curves? I don't want to try that. Oh.
All right. What do we do now? Derive it. Why do we derive it? Because we're trying to maximize it. As soon as they say max, or sorry, we're trying to minimize it. As soon as they say max or minimize, that means you're looking for the top of the curve or the bottom of the curve. What is the slope at those points? 0. So you have to take the derivative and set it equal to 0. That's how you find the max and the min. I'm just going to call it A primed. You get 4 pi r minus 2,000 r to the negative 2. Now you set it equal to 0 because you're trying to max it or minimize it. And then I'm going to solve for r. So I move this 2,000 over. I'm going to multiply the r up and divide off the 4 pi. I'm doing this quickly because I get that. So if I want r, I cube root all that stuff. .42 centimeters, I think. Okay. How do you prove it's a max or a min? Is this? I don't know what units we're in. Yeah, it's centimeters. Sorry? Okay, so you can do first derivative test or second derivative test. I'll show you both. No. You have to, if they want you to show it's a max, how do you know this is a max? Or a min, sorry. You don't, just because you're just assuming it is, right? You don't know though. Yeah, but the whole thing might be wrong. Like you might have done something wrong and get the wrong answer, right?
Check the answer.
And that- I love your. Okay. The first derivative test says you test either side of your critical point. If you do that, you're going to get it's decreasing and then it's increasing. So therefore, that's a min. Okay. If you do second derivative tests, which is usually easier when you're dealing with functions like this, okay? Because if I do the derivative, it's easy to do the derivative of this, right? But if it's a complex function, usually first derivative test is easier because taking multiple derivatives gets harder and harder, depending on the function anyway. So if I do the second derivative, I have to find the second derivative, which is 4 pi plus 4,000 r to the negative 3. I'm quite positive.
Is there any point in checking both?
No, not unless you don't trust yourself to do something. What do you do for second derivative test? What do I plug into the second derivative? No, you plug that into it. Because what you're doing is we've established that this is a critical point. It's a max or a min. So all I'm going to do is plug that into the second derivative and find out if I get a positive or a negative answer. Are you going to get a positive or a negative? Why?
There's no positive. Well, because
Because it's a positive number that is being cubed, right? So it's positive, and you're adding it to another positive number. So it has to be positive. If the second derivative is positive at the critical number, positive second derivative means it's concave up. If you're concave, so let me say this is positive, therefore concave up, which means it looks like that, therefore it's a min. Does that make sense?
Yes, love that.
All right, we got 10 minutes to do a related rate problem. Well, to find them, then you just plug it back. I'm not going to do it, but if you want, what are you trying to find? Find the minimal surface area? Okay, so once you found R, plug it into this formula. Okay? All right. Rate. Yes. Yes. Okay, same test. We are going to, here we go. The classic. Look at this guy was even nice. He even titled it Related Rates. Last question of the day. Last question of Math 100 before your final exam. Here we go. A ladder 8 meters long is leaning against a wall. If the base of the ladder is pulled away from the wall at a rate of 0.5 meters per second, how fast is the top of the ladder sliding down the wall when the base is 1, 3, 7? Which one do you want to do? 1, 3, or 7? No, we're not. Let's just do 1. Okay. Draw a picture. There's the ladder. The ladder is 8 meters long. Okay, is it 1 meter away? Okay, whoa, slow down, peoples. The base is 1 meter. Okay, this is 1 meter. It's on the Baldwin scale, so let's not worry about that. Okay, what are we doing? We're pulling. The ladder's going this way, and this is going down. This is X. This is Y. What shape do we have, peoples? Triangle. If we don't involve any angles, what is the only equation that we have for a triangle? Hypotenuse. I think your brains have gone sideways here. X squared plus y squared is equal to r squared. What is constant in this whole thing and never ever changes? The r.
This is a implicit differentiation equation, right?
I don't know what that was. I think I've lost my brain. Okay, so this is the equation. We want to derive that. With respect to, when you're doing rates, it's always with respect to time. Because it's 8 squared. Because x is changing. We can plug, because you're pulling the letter out, right? All right, so I get 2x dx dt, 2y dy dt is equal to, what's the derivative of a constant? 0. Oh my gosh. What are we even looking for? How fast is the top of the ladder? Okay, I'm trying to figure this out. That was going to be so much more dramatic. No, I was trying to be dramatic. There we go. How fast? Wasn't that dramatic?
You missed the L. Why are you multiplying the adder sliding down?
Okay, hang on. How fast is the ladder sliding down the wall? I'm basically saying, what is dy dt? That's, I can't even write anymore. Dy dt. That's what I'm saying, right? That's what I want to know. Correct?
Yes.
All right. Manipulate this formula to find dy dt. So, does everybody agree with that?
Yes.
That is my formula to find dy dt. Negative x over y dx dt. I just algebra'd it. Thank you. Yeah? I'm not listening to you anymore, Jackson, because you just say yes to everything. Is everybody good with that? All right. Yes. It's being pulled away from the wall at a rate of 0.5. That means this is changing at 0.5, right?
Why do we need that equation in black?
Because that we're trying to find how fast it's sliding down the wall.
Okay.
That's how fast the y is changing with respect to time. So that's dy dt.
Okay.
All right.
We already know how fast the x is changing relative to time.
Yeah, that's the 0.5. Okay. So we know when it's a meter away. What's the only problem and the only bit of information we do not know yet? We don't know the y value. We know that when x is equal to 1, the rate is going at 0.5, but we don't know what y is, and we need to know y for our formula. How am I going to find y? Find it by doing that, right? So I go 1 squared plus y squared is equal to 64, so y is equal to root 63. Is that okay? Yeah, is that right? Are we good? Are we good? Are we good? No, that's y. So dy dt is x, negative 1, meters, divided by root 63 meters. That makes a lot of sense. Times dx dt, which is 0.5 meters per second. Is that okay? Did that make sense? I did it really fast at the end. I don't know. It's not going to be nice. You want an actual answer?
It's
Negative 0.06.
negative root 7 over 40.
Meters per second, right? Because these two meters here cancel. You left the meters per second. Is that okay? I don't really care about the numbers. I care about, do you understand what you were actually doing?
So basically, when you're driving that equation, you're taking the x squared and y squared.
Yeah, because it's with respect to time.
Yeah, and then you're setting it to 0.
Because the derivative of this doesn't change.
Oh, right.
The ladder doesn't change, right? So it's 0.
You're just taking the derivative off and plugging
Yeah. Yeah. Okay, so